Welcome to Red Canyon National Conservation Area at night. I'm Ranger Anica, and tonight I'm going to talk to you about night vision. Night vision is a form of adaptation that some animals have to help them see and live better at night. And you might notice this is going to be our third video covering some form of adaptation. There were summer adaptations, winter adaptations, and now night adaptations, but just the vision, because this is a broad topic. So why, Ranger Anica and Ranger Tom, why do you guys keep telling us about adaptations? It's because adaptations are so cool. Think about it. This entire planet, we've got deep, deep seas and tall, tall mountains and hot deserts, which are not very hot right now. It is really cold. And cold tundras that are always cold and everything in between. And yet there's plants and animals all over this place. And we're able to survive in these different environments because of our adaptations. And I just think that's fascinating. So hopefully you guys will find this a little fascinating too. Now, normally I would love to start this off with showing you your own night vision, but I don't think that's going to work with the screen. So we'll see if we can figure something out. So if you can find a dark place, either it's dark right now or your bathroom or your closet or somewhere where you can be somewhere for about 5 minutes in the dark, and go there, and I want you to close and cover one eye and keep that eye closed and covered the whole time, and then just sit and hang out for 3 to 5 minutes. You could listen to a song, you could watch one of our videos like this one, whatever, just hang out for about 5 minutes. Just make sure you keep the one eye closed and covered the entire time. And it doesn't matter which eye, just make sure it's the same one the whole time. And then when you're done, I want you to look at a light, either turn the lights on real quick or the flashlight of your phone, something bright, turn it off, and then uncover and open your eye. And hopefully you'll be able to see night vision in one eye and not in the other eye. So pause this video and try it out, maybe? Oh wait. Did it work? Hopefully it did. This is one of the few times technology isn't really helping, but if it didn't work so well, try again when it's darker out, or stay for a little bit longer, like 10 minutes, and then try again. Hopefully you get at least a bit of your night vision in one eye and your normal vision in the other eye. So why does this happen? Well, we are diurnal animals, which means we're active during the day. Diurnal. Just to let you know, there's going to be a lot of fun words in this video. So we're active at day, and you might be familiar with nocturnal, animals active at night. And I mentioned this in a different video, but it's a good enough word to repeat. Crepuscular animals, crepuscular, which is active at dawn and at dusk. As diurnal animals, we don't have good night vision because we didn't need it. So we didn't get it. What we do have that helps us see at night is something called rhodopsin, which is probably my favorite word of this video. Rhodopsin. And rhodopsin is also known as visual purple, if you can't remember the longer word, and it's what helps us see. Rhodopsin builds up over time. After you've been in the dark for about 5 minutes, you're going to see pretty good as we can do see. And then after a half hour, that's as good as it gets. So if you've been waiting in the dark for your night vision to get really good, if you've been in the dark for a half hour, that's it. That's as good as it's gonna get. And it works pretty well. If you trust yourself and go try out where there's no lights, without a light on, and let that rhodopsin build up, I think you'd be amazed with how much you could see. But it does come with a big negative. It's photosensitive. And what that means is when it's exposed to light, it evaporates. This is why when you go to the bathroom in the middle of the night, you can see fine to get to the bathroom, and then you flip on the light, and then when you turn it off, you can't see anything because you just evaporated all your rhodopsin. You got rid of all of your night vision. So this does work pretty well, but I don't know if you've noticed, there's something missing. Do you know what it is? Let me adjust the camera first. Okay, now this is what it would look like if you were actually out here talking to me. What changed? Well, what color do you think this is? Ah, so this blue, this one is green, yellow, pink. That one's just white. So yeah, we can't see color, not at night. Why is that? Well, it's how our eyes are made. So you've got rods and cones in your eyes, which you've probably heard of before. The cones are responsible for color, and you can remember that with cones color. But the cones require a lot of light to work. More light than you have at night, so they're not working at all. What you're seeing is all from your rods, and your rods don't detect color. So that's why no color at night. But I'll bring it back for you. So that's how we see at night, or don't see at night, depending on how you want to think about it. But what about the animals that can see at night, the animals that are nocturnal? How do their eyes work? Well, one of the things is a lot of animals have a tapetum lucidium, which is another fun word, tapetum lucidium. And what that is this thin iridescent coating in the back of the eyes that helps reflect light. It kind of acts like a mirror. So if you've seen a cat or other animal at night and it looks like their eyes are glowing in the dark, what you're seeing is that tapetum. It's the light reflecting back, not their eyes glowing in the dark. Because of this, they can see in so much less light than we can. A house cat, it's 1/6 to 1/8 the amount of light that we need to be able to see. Beyond the tapetum, you might notice some other differences in the eyes, like the pupils. House cats, or our very own kit foxes, will have these slit pupils, and that allows so much more light in. It also helps them with depth perception, making it easier for them to find their prey. In addition to that, these animals tend to have a lot more rods in their eyes. So they might not have a lot of cones and their color vision might not be great, but they can see much, much better at night than we can because they have all those rods. One animal that sees really well at night that does have a lot of rods is an owl, and they also have pretty interesting eyes. So most eyes are spherical like ours, but theirs instead is cylindrical. And their eyes are so big, so if we had eyes the size of an owl, like in proportion, imagine you take like 2 cantaloupes and stick them in your head. That would be how big your eyes would be for you to be like an owl. So they're huge, and as you can probably imagine, how are you going to keep these cantaloupe eyes in your head? Well, that's why they're that cylindrical shape, because otherwise they would just fall out. And so they have these things called sclerotic rings, and they keep the eye, and it keeps it in shape and gives them binocular vision. The downside to that, though, is then they can't move their eyes around like we do. And that's why they have that other adaptation where they can turn their heads 3/4 of a circle around. I'm not going to talk anymore about owls because Kate did a great video about it, so you should watch that too. In addition to changes in eyes, another adaptation to see at night is not to use your eyes for it, or help those eyes along. Bats, for example, use echolocation. They can see. Blind as a bat is a misnomer. Their eyes do work, but they don't see as good as an owl at night. And what they do instead is they will release these high-pitched noises we can't hear that'll go out, and when it hits something, it'll echo, and they can see what things look like from those echoes, which is actually pretty fascinating. Other animals that don't see but can have good night vision are pit vipers. These snakes have these organs that do thermal vision. So they're seeing like the thermal image of what these prey animals might look like. So that's just the tidbits of how our eyes work at night and some of the animal adaptations to help them see at night. If you guys want to learn more about night adaptations, let me know, and I'll force myself to be out here at night again and enjoy these beautiful stars. But until then, I hope you had fun, and I'll see you next time.